Okay, section A2, page 418. Arithmetic sequences and series. So I'm going to try to see if you can follow me and help develop the formula we're going to use for arithmetic things. You know, describe what arithmetic means, come up with some rules and things. We got three. I'm just going to ask you to consider this sequence. And it's a sequence when there's commas, remember? 3, 7, 11, 15, 19, 23, and so forth. And I want to go clear up to, I want you to focus on this. This is what we tried to do in A1. This is the first term, which we call A1. A2, A3, so forth. I know this is boring to watch. A5, A6. And what I want to know is how could I come up here without generating all the terms before it and find an AN? I want to know what that is without having to go all the way up there. And I would like to be able to do it for any n, like 10 or 50 or 100,000. I don't care which term number it is. I would like something that I can find that term number without generating all the other ones before it. So I've got to take a look at a pattern here. So just bear with. Well, first of all, look at that sequence of numbers. Tell me what do you have to do to generate them? What do you do to 23 to get the next one? Add 4. Is there a gap of 4 every time? Yeah. 3 plus 4 is 7, plus 4 is 11, plus 4 is 15, and I think you saw that, right? So we call that number 4 that we just discovered, we call that the difference or the common difference. It's the common difference between any term and the next one is 4. And we use a D to represent that. So D is 4. That's the first thing you've got to discover. And if D is 4, then I'm going to do pull the same thing I pulled on you, and I say, well, every time we got to do it, I'll multiply by another 2. I want you to consider writing this sequence like this: 3, comma, 3 plus 4, comma, 3 plus 4, that's this one, plus 4. Isn't that what we're doing every time, is adding another 4? 3 plus 4 plus 4 plus 4. And then you can see how that's going to go. And if we split it up this way, every time we start out with a 3 and we add on, remember, this is the second term. This is number 2 term, and there's only one 4. This is the third term, and there's only 2 4s being added. This is the fourth term, and there are 3 4s. So what I'm saying is I'm going to multiply by 4 this many times. Did you catch that? Whatever term number I'm on, one less than that term number is how many 4s I need to add to 3 to get the next one. You okay with that? That's AN in this case. That's how I generate the nth term. If I want to know what the 50th term is, I'll take 4 times 49 and add 3. Because by the time I get to the 50th term, I will have 49 4s being added to 3. That make sense? Then in general, if we consider this is for this term, for this sequence. If I wanted to do it in general then, and then summarize it, extrapolate it to everything, then I would say that AN for any term is equal to the first term. That's what 3 is. Plus N minus 1 D, where D is the common difference. Does that make good sense? Okay, that's what I'm going to put up here. I'm going to try to keep track of things. For arithmetic sequences. Oh, if I could write legibly, hang on. For arithmetic things, and by the way, arithmetic is characterized by a common difference, or adding, not multiplying, but adding the same thing to get the next term every time. Arithmetic is addition. Arithmetic is addition and subtraction. When we do the geometric ones tomorrow, I'll bring this all together into a single thought with order of operations. But for right now, arithmetic, the nth term, we call it. The nth term generator for an arithmetic sequence is the first term plus n minus 1d. And this is how it's written in the book. If you prefer to have that d in the front, that's fine. You can do that. You can write it that way or memorize it that way. That's how we're going to write it. Okay, so with that in mind, I want you to look at how many variables there are. This is the term that I seek, or the last term. If they give me this, I've got to plug a number in here, not the n, but the value. Like if I was going up here to the 50th one, I would want a big fat number right here, and I would put it here. A1, First one, usually they give you that. How many are we going to do? That's one less than that goes here, and then you got to figure the common difference. And they give you different things with different scenarios, with different variables missing. We got to play around with it. See what's wrong. So take a look at example 1 first. Let's see if you can decide if they're arithmetic. Example 1 has -9, -2, 5, 12, 19. What you do is you say, how do I get from -9 to -2 on the number line? You add 7, yeah? How do I get from -2 to 5? Do I add 7 again? Yes. If I add 7 to 5, do I get the next one? Yes. And if I add 7 to 12, I get the next one. So not only have we discovered it's arithmetic, we've discovered the common difference is 7. Look at the next one. 23 to 15. Now we're going back down. But 23 to get to 15 is -8, right? 15 minus 8 is not 9. So this one's not arithmetic. You can have a common difference that is negative. It just means that your terms are marching down the number line instead of getting smaller instead of going up. But your common difference can be negative. This one didn't have a common. Okay, so everybody look at number 2 on the monitoring progress. This is on page, right near the bottom of page 418, just before the core concept. It says monitoring progress number 2. Everybody decide, arithmetic or not? I've seen several people nodding, so I'm thinking, are you coming up with the idea that it is? What's the common difference? -6, because when numbers are going down, we're adding -6 or subtracting 6 each time, right? So the common difference here is -6. Were y'all able to see that? I hope you all tried it. I only saw a few nods, but I hope the rest of you tried it. Okay, example 2 says, write a rule. This is a rule. It's a general rule for all arithmetic sequences. We're going to make it specific to a particular one here. It says, write a rule for the nth term of each sequence, then find A15. So we have 3, 8, 13, 18. 3, 8, 13, 18. Okay, the nth term is going to be the first term plus n minus 1. That's just a variable, n minus 1. But what's the common difference? 5. Now, if you write this down on the test that you're going to take at the end of the chapter, this right here, it'll cost you because it's not completed. It's not done. This is the stuff you put in, but I want it to look like y equals mx plus b. In other words, I want it simplified. So we've got to do a little bit of work. It'll be 3 plus 5n minus 5. Yep. See that? Distributing from the back end, same as distributing from the front. And then I got to combine these two constants. So it should be 5n minus 2. That should be your nth term generator. So once you write down using those, you got to clean it up. So this would be what you would write in the blank, and then you would say A15 and plug in 15 for n. 5 times 15 minus 2, and that's 73, because that's 75. Yeah. Okay? So this would be the other answer. So they want you to come up with this in a nice cleaned up way, and then use it to find a rather large one that you don't want to generate all the terms for. Okay? Let's try the next one. 55, 47, 39. 55, 47, 39. Is that arithmetic, first of all? 31. Okay, so we have, what's the common difference? -8, because we're marching on down. We got to subtract 8 each time. And A1, we can tell is right there. I'm not even going to write that down. So the nth term starts out as the first term, A1, plus n minus 1 times -8. Clean it up. 55 minus 8n plus 8. See it? All the distribution. 55 and 8 is 63, so it's -8n plus 63. Looks like a line. Y equals m. M is -8. That's what we drop each time. Plus this is the start point. You're going, the start point's 55. No, it starts at 63 if n is 0. So what I'm saying is it's very much like a line. I'm hoping I can straighten this out for you, this idea. Because you get that written like that, and you go, well, it says that we got to start at 63, and this says we're starting at 55. Okay, so I want you to take a look at these pieces of this. If we were to graph that thing that we just wrote, the nth term formula, I would start up here at 63. But by the time I got to my first term, which is what these are term numbers, if you graph it. These are values, term values. You see, by the time I get to the first term, I've got to come down 8. By the time I get to the first term, I am at 55. Because this is the 0th term. This is where it crosses the 0 line. I start my sequences with the first term. That's why that generator's got to be at 63, not 55. That's I have to do with the n minus 1 thing. Anyway, so this is my nth term generator, and A15 would be then negative 8 times 15 plus 63. And I'm not good enough to do that arithmetic. 15 times 8.
Negative 57.
Okay, thanks. So you would write this as part of your answer, and this, that's the 15th term. See how it's going to go? You all right? So you plug it in, but then clean it up. Okay. If there's any questions so far, you let me know. Example 3. It says one term of an arithmetic sequence, the 19th one, that's what they're saying. A19 is negative 45. The common difference is negative 3. Write a rule for the nth terms. They're not giving us a sequence where we can see A1 and all the things that we need to write it. They are giving us some information. We got to go find the rest. So I'm going to show you how to read this properly. It's kind of interesting. Let me get rid of this stuff first. So you're still using the same formula right there, and they're telling us that the 19th term is, what did it say, 45?
Negative 45.
Negative 45. And that the common difference, they're telling us that is what? Negative 3? Mm-hmm. Okay. So we have to write an nth term formula. I'm going to write it right here so we have it right next to us, don't have to keep moving our eyes around. They didn't tell us this. Ooh, but they did tell us this. For one particular instance, it's 19. That's where that's going to come in. So AN means A19. I mean, that's the one we're going to use to find the things that's missing. I'm not actually going to write A9. Well, I'll write it down. I'll go ahead and write it down so it's in steps. Plus 19 minus 1 times D. And I'll put the stuff in just a minute. But I'm just saying, they're giving us a snapshot. They're giving us an N value right here. But A19 doesn't go here. Negative 45 goes there. That's the value of A19. Equals A1 times 18, or plus 18 times negative 3. Can you see that that leaves us with an equation that only has A1 in it, the thing that we're missing? So we got to go solve for it. I have negative 45 equals A1 plus 18 times 3 is 54, so it's negative 54. Got to add that to 45, I get 9. Did I get this right? Is that arithmetic correct? Mm-hmm. Okay. So if A1 is 9, now we write the nth term formula, come back up here now that we know all the pieces, and we write AN is going to equal 9 plus N minus 1 times negative 3 and clean it up now that we have all the pieces. But we had to go find the pieces using a specific set of values where the 19 is very useful right there. And we also have to put the value of A19 right there. How are we doing? You see what's going on? The value goes here, the number 19 goes here, so that we have one equation written with just one variable, and we solve for that, and then we write everything we're supposed to, like we did before. Now that we have all the pieces. 9 plus, or actually minus 3n plus 3. So the nth term formula for this particular set of circumstances is going to be negative 3n plus 12. But in giving us this information, they actually gave us 3 things. They gave us a value along the way. They gave us an n value, an n for which this is the 19th term, and a d, which left us with only one thing to solve for, a1. Then we go back and write the nth term formula. So this is the answer to that question. See, it's kind of crazy. Sometimes you got to take a snapshot that they give you of the sequence, a piece of the sequence, find the missing information, and then go after the writing of it. It's not as easy as it was the first time. Okay, take a look at example 4. This one's going to be even more fun. Ready? Fun, great. You love it. You guys are acting so excited today. All right, so I'm going to erase this, And if you can't remember how to do it, go look up this video. Take a look at it again so you can see if you can make it apply to yours. This one's more involved than ever. And you might want to use your calculators on this because I'm going to show you a trick with your calculators. It'll make your life a little easier if you can get it written. What it says is that A7 equals 17 and A26 equals 93. And that's all you get. These are two different term numbers in this sequence, and we have to write the nth term formula. So please pay attention rather than write this down. Don't go to sleep on me. Are you ready? Here goes. It's kind of rough. You got to pay attention on this. We're going to write an nth. We're going to use the nth term formula for this information right here. That would be 17 because that's the nth. That's the seventh term. So that's what goes in the an spot. Equals a1 plus 6 because that's n minus 1 d. Did you follow all that? I've got an A1 and a D. I can't solve this equation uniquely for either one of those. So we do the same thing over here. Gives me 93. That's the nth term formula equals A1, which I don't know, plus 92. No, sorry, 25. Wrong number. 25 times D. And the A1 here and D here are exactly the same as the A1 and the D here. I just don't know what they are. But if you'll remember from Algebra 1 and maybe a little bit of Algebra 2 earlier, if you have two equations with two unknowns, you should be able to solve it. So when I say that, I'm going to come back to this in just a minute. I want to remind you of the concept that we're after. Do you remember in Algebra 1 and probably earlier in Algebra 2 when we had stuff like this? 2x minus 4y equals 7 and 3x plus 8y equals 12. They stack them up like that and they say find the value of an x and y that makes this true. Do you remember that? And the objective was, for example, we might multiply this one through by 2 to get a negative 8. We would have, and I would write the result down here would be 4x minus 8y equals 14. And you would draw a line. These would add up to 7. And this would add up to 28, 26. Sorry, I just threw these numbers up here, so it's not going to come out nice. But x would be 26/7, remember? And then you would take the x and plug it back in. Remember doing that? Now, did you know that you can solve this system in your calculator? Come back to here. I'm going to show you how to solve this very system. And keep in mind, I made it up, so it's pretty ugly. You take that system as is before you did anything to it or tried to solve it, and you can get your calculator to solve it if these are linear. And they will be. They're linear, meaning they're not quadratic or exponential or something like that. So grab your calculators. It's in that same polyroot finder button that you had, only it's the number 2, simultaneous equation solver. So we're going to go to apps, Polysmol 2, and it says polyroot finder, and then it says simultaneous equation solver. We're going to choose number 2. Okay, and what it wants to know in this next screen is how many equations. If you're there, we're talking about the first 2 lines. Okay, so it says how many equations? 2. If it doesn't say 2, then move your cursor over till it says 2 and hit enter. How many unknowns, meaning how many variables? 2. Those are the only 2 decisions you have to make, and then you push the button next, which is the graph button. And it wants you to put these things in. They have to be lined up, x's and y's and equals and constants. But once they're lined up and you got them organized, you go 2, enter. I'm going to hit a minus sign, and then 4, enter, and then 7, enter. And it jumps down to the next line, 3, 3, enter, plus 8. Not negative 8, just 8, 12, enter. And then when you got them all entered and it looks like that up there, then hit solve. And they came out ugly because I made it up, but you get the 2 solutions for x and y, right? Okay, so that's what we're going to use here because these 2 equations, even though they're not really cleaned up very well, they are both linear because there's no exponent other than 1 on the variables. But we've got to line things up so it looks right, so it looks like what we want. So I'm going to do a little bit of maneuvering here. This one I'm going to rewrite as A1 plus 6D equals 17. All I did is toss the 17 back over here. I mean, equal signs are reflexive. You put 17 on either side without changing a sign. This one over here then would be A1 plus 25D equals 93. And if I stack them up like this, A1 plus 25D equals 93. Now it looks an awful lot like that, except for we've got A1 and D instead of X and Y. So when your calculator returns to you an X and Y value, you have your A1 and D, and you got to know which one's which. So go back to, if you've already got that pulled up, that I didn't, I lost it. Yes. Holy smoke, 2, simultaneous, 2 and 2, next. So now I'm going to put in there a 1, because that's the coefficient on A1. A 1 plus 6 and a 17. 1 plus 25 and a 93. Is anybody having trouble entering this? If you hit solve, you get that A1 is negative 7. And the common difference is 4. That's what X and Y mean. Are you there? Now we can write the nth term generator. We haven't even written the problem. We haven't tackled that yet, but we now know these two things, which is what we needed. An then will be equal to negative 7 plus n minus 1 times 4. We've got all the pieces we need. Clean it up. This generates these two terms, this as the 7th one, this as the 26th one, and every other term that you want to find out. But you got to solve a system of equations. This gives you this equation, which is missing A1 and D. This gives you this equation, which is missing A1 and D. And you got to organize it so that you can use this to solve. Or you can use an algebraic method too, if you want. Substitution or linear combinations or whatever. Or you can use the calculator. Most people choose the calculator. But the trick is, and the thing that'll get you the points on the test, is being able to put this together. Because after that, it becomes a calculator pushing exercise, button pushing. Putting that together is what you need to do. Okay? How are we doing so far?
Good.
Okay? All that we've done so far is played around with this formula, which is the formula for the nth term of a sequence. Now we're going to talk about series. Remember, series have pluses and, well, have pluses in between, or possibly minuses if you're talking about negative numbers. But we want to add things up now that are in an arithmetic sequence, but we put plus signs instead of commas in. So I'll tell you a story. Do you know what apocryphal means? Strange word. Apocryphal means that the story you're about to hear may or may not be true. It could be true, but it might not be, and the facts may have been changed. But it doesn't matter because there's still a point to it. It's not like what do they call those when animals come to life and teach you? It's not a fable. It's not that. Could actually happen. Whether it did or not is irrelevant. So here's the story. It's an apocryphal story. There's a guy named Friedrich Gauss. He's one of the most famous mathematicians. You'll see his name pop up in math books from now on. And there's a story that was told about him when he was really young, and he was in a class. It was about probably third or fourth grade. And they were just starting to learn they were getting pretty good at their addition, subtraction facts. Multiplication facts were coming along pretty well. And they were out at recess one time, and somebody did something, I don't know, lit a firecracker and gave somebody or something. Teacher got mad. Teacher says, everybody in the classroom, I don't want to hear one sound out of any of you guys until you've all added up the numbers from 1 to 100. And so Gauss sat down. About 20 seconds later, he came up with an answer. She thought he was being a smart aleck. She thought for sure that she would be able to get all of that assignment done before them because she was better at arithmetic than they were. So she thought he was being a smart aleck. And she said, you get back there and show me your work. And he goes, no, I think this is it. He was very polite, very kind. He said, I bet this is the answer, and I will wait until you get done. I bet you if that's the answer. And the difference between a really, really good math student and a genius is very small. And you'll see in just a second, this is what he did. It's genius what he did. He thought to himself, because if it had been me, and I'm pretty good at arithmetic, by now I'm pretty good, and I would say 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 4 plus 5 is 15. 10 plus 5 is 15, plus 6 is 21. And when I got to a point where I had to write things down, like when I was adding something to a double-digit number, I'd probably write it down and just get after it, and then sum them all up, just keep accumulating. He thought of the end of the problem and the beginning at the same time, and I would have only thought of the beginning. This is what he said. He thought to himself, that's 1 plus 2 plus 3 plus, and then up here is plus 98 plus 99 plus 100. That first one, which is the smallest, plus that biggest one, which is 100, this is what he did. He said, I'm going to add those two together. That's 101. He said, I wonder what would happen if I did the second biggest one and added it to the second smallest one, and I get 101. He said, I wonder if it happens one more time. 3. So he's going to add 3 to 98, which is 101. And he said, okay, I'm convinced. And he said, how many of these will I have? 50. 50 pairs, right? So he went 50. No, he went 101 times 50 like this. And that's correct. No, but that's correct. 5,050 is what the first 100 terms add up to. You go, great. That's pretty cool. Actually, the story goes like this. They've known this. They've known this idea and this whole way of putting it together. They've known that for eons. But he didn't. He was in the 3rd grade, hadn't been taught that. So to him, to do this without ever been taught this is a way to do it, it's pretty genius. It's pretty cool. In a general way, how we can summarize this is, what he did was he took the first term in the sequence, added the last term, 1 and n, whatever the last term is, and multiplied it by n over 2. That's your 50. In this scenario, in this sequence here. This is 100 terms, divided by 2 is 50, because you're going to have 50 pairs of these. Well, I shouldn't say of these, but whatever the first term plus the last term is gives us this number, and however many terms there are divided by 2 gives us that 50. That's n over 2. This is a1 plus an, and we multiply them together. That's what that is right there. See it? Okay, so we call this, if you generalize it to any arithmetic sequence, and it does work for any arithmetic, not just 1 through 100. Anything that's arithmetic, you can do this with. And it is SN, stands for the sum of n terms. We add them up, gives you this. It's not the nth term number or value, it's the addition of all the terms if you know the first one, the last one, and how many there are. That's the trick. The first one, the last one, and how many there are. So I'm going to put this under the arithmetic thing here. Sn is equal to n over 2 times a1 plus an. N over 2 times a1 plus an. That's a sum of n terms. So now we're talking sequence. Not sequence. This is sequences. Nth term. This is series. Series means to add them up. So S stands for sum. Okay, let's see if we can apply that to a problem. Gauss did it that way. Take a look at example 6 with me. No. Take a look at example 6 with me. I'll come back to example 5 in just a minute. I want to take a look at 6. It says, you're going to make a house of cards. You are making a house of cards similar to the one shown. So you got this stack over here. It says, write a rule for the number of cards in the nth row when the top row is 1. Write a rule for the number of cards in the nth row. Does that mean they're asking us to do this or this? The number of cards in the nth row is what they want us to do first. They want us to do this. It's the nth terms, the nth number of cards in the nth row, because there's a whole bunch above it. We haven't added them all together. We just this row. Okay, so we're doing that first one, the one we learned just a minute ago first. So I'll put that over here. AN equals how many cards are in the first row if the top of the stack is the first row. That's what it's trying to tell you. How many cards are there? 3, isn't it? 3 cards in the first row? Yeah, the top thing. That's the first term. This is A1. Means the number of cards in the 1th row, first row, okay? Plus n minus 1, because that's a variable. What's the common difference? Now we've got to think about those rows going. That's the first term, but can you generate some others? Let's do it right over here. We got 3. How many are in the next row?
6.
And the next row?
9.
Is it arithmetic?
Yeah.
And what's the common difference? 3. We keep adding 3 each time. We're still doing the nth term thing. So this is 3 plus 3n minus 3, which is 3n. Nice. Why did we do that? I mean, that's what they said. Find the number in the nth row. So it says, how many cards do you need to make a house with 12 rows? Now they're asking to do this. How many total cards? We want to add up 3 cards in the first one, plus the 6 in the next one, plus the 9 in the next one, and so forth. Do you know what I mean? Now they want us to do this. They want to find out how many cards it will take to make a 12-row house of cards in this way. And so we're going to have to go up to whatever A12 is. And we're going to have to add them all up. And we're going to use Gauss's wonderful formula. So this was A in this problem. B says sum them all up. So I'm saying, okay, the sum of 12 rows, that's what that subscript means, equals 12 over 2, because that's n. These match. Times A1, which we know is 3, plus, how are we going to find the 12th row? How many are in the 12th row? 36. That's why they had us do this first. Because they figure it out rather than just hand it to us. See, guys, this thing right here, that thing, not that thing. This is the last term, in this case, the 12th term. So we found the 12th one by first making this happen for us, which was 3n. Then we can just plug 12 in to get this number, which is 36. This and this are the same. So if you need this in order to sum things up, you're going to have to use this to get it generated. It's kind of cool. So 3 and 36 is 39. 12 divided by 2 is 6. So 6 times 39 is how many cards you will need. What is that? What?
234.
234. Dyslexia. 234. Now, if you buy cards in boxes that have 54, because there's 2 jokers, how many boxes will you have to buy to have enough?
4.3.
Means 5, because you can't buy 0.3 of a box. So go buy 5 boxes of cards, and you should be able to build this with a few left over. Right? Now go back to example 5, because I got to show you how to read this. They've got things written in summation notation again. Here we go. So example 5, we're backtracking a bit, is the sum. This is how they're presenting it. The sum as n, I'm going to write n like you guys want to. N equals 1 to 20 of 3n plus 7. With that summation notation, that it tells you, because that's a capital Greek letter S, they want us to do this. They want us to add all of these up, but I do not want to generate 20 terms and then grab my calculator. That's a little much. So instead, I'm going to use that formula right there. This, asking you to do this, is the same as asking you to do this. N, how many terms would what is n? How many terms? 20. If you started at 0, then it would be 21. If you go 1, 2, 3, 4, 5, 6, 7, 8, 9, you'll have 20 terms. So if this is 1, then this is 20. And this is 20. That means that there are 20 terms. So that n right on top right here, that's 20 over 2 times the first term comes from plugging in the first value right here. That would be 3 plus 7, which is 10. Yeah? That's A1. What's AN? AN is the last term, and that comes from plugging 20 into n, because that would have been the last thing we did, was plug the 20 in. So that's 67. Did I lose anybody on that? First term's value comes from plugging in this number. Last term, which is the nth term's value, comes from plugging in the last of these numbers. And so what I end up with is 10 times 77, 770. That's the value of this, what they're asking you to do, 770. Using that formula without generating 20 terms to add up. Now, I don't know if I'm going to see if I need to show you this. If not. Oh, and there's the answer set. I guess they don't have it. All right. There is a quirky thing if this is not one. If that happens to you, bring it as a question tomorrow. We'll talk about it then. If that never shows up, then we'll just say that this is n. If they ask you to add it up from 8 to 20, you've got another thing coming. If it's 1 to 20 or 1 to 50 or 1 to anything, this is n. But if it's 5 to 20 or 10 to 20, anything other than 1, you got something else to think about. If that happens to you in the exercises, bring that up as a question tomorrow. We'll discuss it then. Okay? This has to be a 1 for this to work. If it's not, you might want to just not do it till we come back tomorrow. Okay? Okay. I probably shouldn't have erased that. I should have left it up there. So these two formulas, we will have 2 more like it the next tomorrow when we do things, and then we'll have 1 more. So there will be 5 formulas like this. My recommendation is, as you do this work, memorize them. As you write it down, use it the first time like a recipe and write it down. Next time you use it, try to remember it. If you have to look something up, look it up. And then next time, try to remember it without having to write anything down, because you cannot have a card or anything to cheat with. Sorry, you've got to have these in your head. Okay? So the assignment is 21 questions on this. You ready to write?
Yep.
3, 5, 11 to 17, odd. 21 to 27, odd. 31 to 39, odd. 43, 47, 49, 57, 61. That seems like a lot because there's a lot of writing. There's 21 questions, which is not unreasonable. Okay? By the time you're done, make sure you have those committed to memory. Sometimes you're going to have to find this using this. So just remember that can be helpful. Good luck.